In this video, we will explore the logging namespace. We'll need to make a reference to the dodSON.Core assembly. First, we will create a file event base logger. That is a logger that will write to a file. The file event base log requires the file name of the log to write the files to, and how it should write the date time in the log, as either local time or universal coordinated time. Then we will open the logger. Then we will write some logs to it. There are a variety of log entry types: Audit Failure, Audit Success, Debug, Error, Warning, and Information. We will use the LoremIpsumGenerator to generate a random sentence with 10 words. After we write 300 logs, we will then read all the logs from the log. We will then close the log and then wait for the user to press any key to allow them to view the results. Compiling and running the application demonstrates writing the logs to the log file and reading the logs from the log file. Here we see the log that was written. The first entry is a date time stamp. The second entry is a human readable date time. The third entry is the log entry type, in this case, information. Following that are the event ID and category ID values, and then the source ID, and then finally the text of the log. We can also create a Windows event log base logger by simply changing the logger to a Windows event log. The Windows event log requires a name for the log, and since the Windows event log does not support a debug entry type, we must specify a replacement event type. Compiling and running the application demonstrates writing the logs to the log file and reading the logs from the log file. Here we can see that the Windows event log contains all 300 events from the log demo. A more advanced use case for the logging namespace would be to create multiple logs based on some criteria. In this case, our criteria will be debug logs, audit logs, logs that are not debug, and audit logs. We accomplish this by creating logs and log filters and putting them into a different kind of log called a log splitter. The log splitter takes any number of log filters. The log filter takes an iLoggable type to filter the logs, and a log to write to. An iLoggable type determines if a log entry is allowed to be written to a log. Here we have created a log filter to filter debug logs, audit success, and audit failure logs, and then to log all of the rest of the logs which are not debug, audit success, or audit failure logs. To write the logs, I will create a random number generator and randomly select between the 5 different log entry types. That is information, warning, error, audit success, audit failure, and debug. Compiling and running the application demonstrates writing the logs and reading the logs. Here we can see that the file-based debug log contains only debug logs, that the file-based audit log contains only audit success and audit failure logs, and the window event-based log, logger demo, contains all of the rest of the logs. A quick calculation shows that all the logs add up to the original 1,000 logs that were written. Log Splitter works like any other logger, writing logs and reading logs regardless of the number of log filters. This demonstrates just some of the capabilities of the dodSON.Core.Logging namespace. Please see the dodSON software help file for more information.